Quintin de Kok. Today he's going to show us his R skills with his talk, A Fiery Approach to R Web Services.
All right, so thank you for the intro. So my name is Quintin de Kok, and if you were expecting this guy, I'm not him. So I'm sorry to say, but I've basically been in the technology industry for 20 years. I'm a proud husband and father, and my background is actually software development. So I know a lot of people here are stats. I don't know how many are software dev, but I'm going to take you through a little bit of a lower level, as a software dev, we try to make things repeatable and optimized and make them simple and easy to maintain. And I think I've got a way to do that with Fiery. So as I said, my background's .NET, JavaScript, a little bit of Python, mostly R. My R journey started 2 years ago, and it's actually at a satRday in 2017. So basically, Fiery Web Services, I'm going to take you through basically three components that we use at Netstar to expose our models as web services. And this is before Plumber API. I didn't actually know anything about Plumber API. But the first is ProjectTemplate. So ProjectTemplate allows us to do things repeatably and have a lot of automation. Fiery, which is a web service that is a web server that is written by Thomas Pedersen that is very, very simple, and I'll get to that in a little bit more detail. And then Docker. Docker is how we deploy these things. So ProjectTemplate is a system for automating the thoughtless parts of data science, right? So that means it automatically it organizes your project files. So when I started with R, one of the team projects we had, the first stumbling block was how does an R project look? We're used to, as developers, a web service MVC model has a certain folder structure. How do you get that right in R? And ProjectTemplate helps with that. It also automatically loads all of your R packages for you. You configure them and it will automatically load them. It also loads all of your data automatically for you from a data folder. And then also it'll do pre-processing. So if you're in an analysis phase, you can put your pre-processing separate from your actual analysis and have it run every single time you load your project. So taking you through that quickly, so essentially what we'll do is we'll install the template, the project template, which is very basic, install quite quick, and then we library that and we can have a look at the create project method. So essentially, if you look at the vignette, the create project has a few parameters, but the ones we're really interested in are the project name, the template, and the RStudio. You can create custom templates, but here in this example, I'm going to use the minimal template. So there we can see I'm creating a project which is called Demo1 on the minimal template, and we're having it create an RStudio project for us. So if you go to the Files tab, you can see Demo1 there, and in that it creates a basic RStudio project or a project template project. And that requires basically five folders: the cache, the config, the data, and the mung folder with the source folder. So in the configs, we can now go and set which libraries we want to use. We tell it to load the libraries, and we also tell it to change the table type to data.frame. The table type isn't really compatible with a lot of our models, so that's something that we do there. So once we've done that, and we've saved that, we can basically go over to loading our project. So once we've changed our configuration and we want to load, this is a new R session. You can see there's nothing loaded on the right. When I do a library on the project template, it'll load that up, and then I call load.project. So load.project in the first instance is going to automatically install all of the dependencies you require. So this is that download that we were talking about earlier. When you do the load.project the second time, you'll see it's much more basic. So here we can see it's loaded our Demo2 project. It's automatically loaded the iris dataset from the data folder. It's also automatically loaded the functions from the lib folder. And it's automatically applied the pre-processing script, which is just a very small script that is in the Mung folder. So there you can see it just basically sets the column names for that iris dataset. So essentially, Project Template gives us the ability to automate a lot of things. I actually found out about this on Twitter. It was by accident, and as they said earlier, most of these things you learn from Twitter. So it really works for us very effectively. So the next component in our framework is Fiery. So Fiery is a lightweight HTTP framework. It's actually not. It's not an HTTP framework. It's an HTTP server that doesn't. It's called Fiery because it's not shiny. Shiny is shiny is very complex. Fiery is extremely basic. It's written by Thomas Lynn Pedersen, and he's also the author of GG Animate, and it allowed us to do a model view-based controller, right? So here's a basic Fiery script. So again, I'm not using Project Template here, but you can see that we load. Oh, sorry, that's the wrong button. Which is the laser. Anyway, it's got the. We load the Fiery library. We create a new Fiery app, and we attach the function to the request object. And if we test this now, using the local host on port 1890. We get our hello world. Right, so that's Fiery basic. If we then add rootar, which is another library developed by Thomas Pedersen, it is actually the middleware that delegates the incoming HTTP URL to different functions inside your project. So yeah, you can see, for instance, we created a new root. We have a fallback function, which will manage all URLs. So the / will, if we get any URL, it will go to fallback, unless we get a URL that says hello, and the who portion is then passed into that function. So we then create a root stack. Root stacking allows us to do multiple roots together. So if we then combine that with Fiery, you can see the same set of code here. The fallback method with its star handler, and the hello world method with its hello who handler. And if you then we add the root and we attach the router to the app. So that attachment is actually a plugin. So Fiery has a plugin framework. If we then run that, we can see that if we do a standard request. Come on, Quintin, code faster. So it will tell you, I'm not saying hello to you. And then if you then add the hello and the satRday, as you can see, the hello satRday is returned to you. So that's a very basic way of doing web services in R using Fiery. You can see it's very, very simple and effective. But the magic really happens when we combine Project Template and Fiery. So I'm going to basically take you through the code. This is essentially what the application portion of your application looks like. So you'll see that there's very little code here, making it maintainable. And all the load library does is exactly what we'd expect it to do. It loads your model. There's the K-nearest network nearest neighbor model loaded. And then it starts up the web service. It's also already created the functions for the handling. So if we do a standard URL request, we get it's a bad request. Please ensure that you've used the right path and method. So you'll see there, it's, for instance, requires posts. So if we then do a curl with a non-standard JSON, it'll tell you that it's expecting a JSON format, and you sent hello or satRdays. And if we then do a curl with a predict, and we pass it the JSON file, you can see the results from the iris K-nearest network test. And there's the JSON that we submitted through. So that's just the test portion of the test and train data set. So that's our web service in Fiery with Project Template. The code is extremely simple to follow. It's modular. It can be added to. It's maintainable. So I'm very happy as a developer. So the next portion is how do we get this into production? So I don't know who uses Docker. Docker is a system for virtualizing software at an OS level. It was open sourced in 2014, and basically it allows you to do an install once, run anywhere scenario, right? So when you create a Docker, it creates what's called an image. That image is a reproducible installation that can be deployed anywhere. And I'll take you through that now. Stefan Fabel, who's the product manager at Canonical, is quoted to say the containerization craze shows no sign of abating. And I think that's true. I think in my environment, definitely, and if you look at what's going on in the cloud, where everybody's moving to containers. So basically, a Docker file is required to create a Docker. And this is really a layered structure, right? So the first portion here is the inheritance. So it inherits from the base R Docker. That is a Docker that has been published on Docker Hub. I'm not sure by who. And what will happen is when we do the build, it'll first execute the from and download that base R. And then what we'll do is we'll apply operating system level updates. This is a key trigger, right? So Fiery, for instance, requires OpenSSL and libxml and libssl inside the operating system to work correctly. So we need to install that, and we use standard Linux commands. In this case, this is a Debian distro, so we just use apt-get install. And then we create our minimum viable project template folder structure. So we need a cache, a data, a source, a mung, and a config. And what we then do is we also copy the configuration from our existing project into the Docker, and a file called install.r, which I'll show you now. And then we run, while the Docker is building, we run the install.r file. And basically, this is what the install.r file looks like. It should look familiar. Essentially, we're just loading the project template library and calling load library. So, of course, that is going to kick off all of the installations of all of the dependent packages. So I'll show you what that looks like quickly, right? So if we go to the Docker folder, and we do a Docker build command. So the Docker build command is very, very simple. It's just basically Docker, okay, first we copy all of our contents to the app folder inside the Docker folder. So what happens when the Docker is created? This entire folder gets copied to a staging area. And then when we do the Docker build, you'll see the first thing it's doing is the from, and there it's actually loading the library from the internet. So luckily, because this is all pre-recorded, we don't have to wait for the 200 megs to download. That's what it looks like after it's done that. And yeah, you can see the next steps running, right? So that is to actually install the operating system updates, as well as the operating system dependencies that we need. And then once it's installed all of those operating system dependencies, you can see it's doing the copy of the app, or at least the creation of the minimum viable project template folder structure, and then copying the configuration into the Docker, and then it executes the install.r file. And that is going to install all of the dependencies. So yeah, you can see the end of that. And yeah, we can see if we do a Docker images, it's created our r-prediction-API Docker version 0.01. If we then do a Docker run, and the command here is basically Docker run, we name our container r-prediction. We want to publish the 1890 internal port on our current machine, and we want to run the r-prediction API 0.01. When we execute this, you'll see it's extremely quick to load. So it's exactly what we did initially, and this now on any machine where this Docker is copied to, it'll execute in that time to load up. So there's no initialization, none of that stuff has to re-happen, and that's what makes Docker really, really attractive. And that's basically me.